Hello, Johanna speaking here. My name is YOHANA ELISABET and my ID number is 419-113-1027. So today I want to explain about the chemical bondings with a topic that has been set by my lecturer because this is the final exam for my subject which is workshop learning media. So let me explain it. So today I want to explain about the other chemical bonds related to the nature of compound with formations of hydrogen bonds, van der Waals forces, London forces with the subtopic by me, Johanna Elizabeth. So this is the learning outcomes. We just be able to distinguish the theory of the formations on chemical bonds, and for the indicator, analyzing the relationship between the type of bond and the physical properties of a substance. For the outlines, the first one is intermolecular forces. The second one is physical properties of molecules and the types of intermolecular, which is van der Waals, London forces, hydrogen bonding, and then conclusions and also questions and discussions. So for the first one is intermolecular forces. Intermolecular forces are the forces that occur between one molecule and another. In principle, this force is an electrostatic force that occurs between molecules apart from each other. And intermolecular forces have a considerable influence on the physical properties of a compound. Some of them are boiling point, freezing point, solubility, and also density. Then another influence is related to the path of a substance. We usually find various kinds of substances, either in molecular or elemental form, always have different passes. As a result of this influence, high energy is needed when you want to melt a solid and or to vaporize a liquid. And then, what is the physical properties of a molecule? The physical properties of a molecule are determined by the attractive forces between molecules, including the boiling point and melting point. The London force causes the melting and boiling points of the molecule to be lower than that of other molecules with the same relative atomic mass, in short, EMR, which do not have the London force. If the molecules are small, these substances are usually gases at room temperature. Molecules that have dipole-dipole attractions cause boiling points or melting points to be higher than molecules that have London forces on molecules with relatively the same molecular mass. This is because the dipole-dipole attractions are stronger than the London forces. So, what are the types of intermolecular forces? So, the first one is van der Waals. Van der Waals forces can occur in molecules that are polar or non-polar, which are caused by the mutual repulsions between electron clouds on atoms. In polar molecules, this force is known as the dipole-dipole force, while in non-polar molecules, it is called the London dispersion force, or commonly known as the London force. For the dipole force, dipole-dipole force are the forces that occur between polar molecules. Actually, this force is an electrostatic force caused by the influence of electronegativity values in an element, so that the magnitude of the dipole moment is influenced by the strength of the attractive force between positive charges and negative charge in a compound. And then we can see this is the CCl4 compound and then CHCl3 compounds. Whereas the CCl4 is a non-polar compound and CHCl3 is a polar compounds.
And from the picture, we can see that the two molecules above are each a covalent bond compound. However, the two compounds have different polarity values. The CHCl3 compound is a polar compound because the Cl atom is more electronegative than hydrogen. So this bond pair will tend to be attracted to the Cl atom, whereas for the CCl4 compound, it is a nonpolar compound in which the covalent bonds that occur in this compound do not have too much difference in electronegativity, or the attraction left and right are equally strong. And then the second one is the London force. London force is a force that occurs as a result of induced attractions as a result of the presence of temporary dipole-dipole forces in a compound. So we can see this is the figure. And the bigger the molecule, the easier it is to form a London force with a momentary dipole moment. This is caused by the presence of electron clouds with more easily impact on large molecules. Therefore, the magnitude of this influence can also affect the boiling point of a compound. The stronger the London force that occurs, the boiling point of the compound will be higher. And then the descriptions of the process of the London style can be seen in the picture above. So when the atom in a time, and then it appeared the dipole in the atom, and then when the dipole can affect the molecule, the dipole is occurred. And then how about the hydrogen bonds? You can see the figure, which is methanol and water. Hydrogen bonds are bonds from interactions between molecules containing N, O, and F elements, especially in elements that have a greater electronegativity value. This says at the same time makes the average of the compounds that form hydrogen bonds is a polar compound. For the examples of simple polar compounds that contain hydrogen bonds can be seen in water and alcohol, which is methanol molecules. Both of these compounds have elements O and H, each of which creates an attractive force between the molecules as shown in the figure. And then you can see, of course, the boiling point of the hydrate compounds in a 6A group. So the tensile strengths of the hydrogen bonds affect the boiling point of a compound, where the stronger the hydrogen bonds that occur, the higher the boiling point of the compound. Let's try to compare the boiling point strengths of hydrate compounds. From the graph, we can distinguish that the strengths of hydrogen bonds can affect the boiling point of a compound. H2O has the highest boiling point among other hydrate compounds. Conceptually, by molecular weight, water has a lower boiling point than H2S, H2Se, and also H2Te. Of course, this is greatly influenced by the hydrogen bonds that are owned by H2O. Meanwhile, the H2S, H2Se, and H2Te compounds only have dipole-dipole interactions that get stronger with the size of the hydrate molecule. And we can see also, this is the figure in the above. We can also compare other examples to the elements of the halogen group, which is 7A, and the HF molecule has a higher boiling point than the other halogen elements. This is also caused by the presence of hydrogen bonds that occur in HF molecules. The graphic comparison can be seen in the picture beside of this in the above, and for the below, from the description, we can conclude that hydrogen bonds greatly affect the boiling point of a compound from other elements in its group. On the other hand, hydrogen bonds can only occur within the same molecule, but it can also occur in different molecules. So through all these observations, we can understand that hydrogen bonds are a type of bond formed from dipole-dipole interactions that have H atoms bonded to N, O, and F, as in H2O and H3, HF, CH3OH, and etc. So the conclusions that we get: van der Waals forces are weak intermolecular forces that allow liquid and solid passes of covalent substances to occur. And then the London force is a weak intermolecular attractions created by a temporarily induced dipole. And then hydrogen bonding is an intermolecular attractions caused by the attractions of two atoms that have a much higher electronegativity value than the H atom, which are covalently bonded to one of these atoms, such as N, O, and F atoms. So how about the questions and discussions that we got? For the first one, what about the boiling points and melting points of compounds whose relative molecular masses are very different while both are polar? And how do hydrogen bonds affect the physical properties of a compound? Let us discuss it. So this is the discussions. You can see this is the table of the name of the compounds, and then the pattern, and then the MR, and then also the boiling point. So from the table, you can see that HI has a higher boiling point than chloride acid. So it is more polar than iodide acid. Why? Because the relative molecular mass of iodide acid is greater than that of chloride acid. So the boiling point of iodide acid is higher than that of chloride acid. This shows that the London force is more usable in comparing the properties of substances with much different relative molecular masses. So, hydrogen bonds affect not only the boiling and melting points of a substance, but also its solubility in a solvent. Compounds with hydrogen bonds dissolve easily in other compounds with hydrogen bonds. So, hydrogen bonds affect not only the boiling point and melting point, but also its solubility in a solvent. Of course, compounds with hydrogen bonds dissolve easily in other compounds with hydrogen bonds. So, the second question determines which compounds have intermolecular dipole-dipole forces in the following compounds: ASH3, BCl3, and Cl2, and specify which polar compounds. So, this is the answer. Compounds that have dipole-dipole forces are compounds that have different electronegativity values in the bonds they form. This is also a sign that the compound is polar or not. Based on these three compounds, the ASH3 compound is a polar compound, while the others are not. Why? Because in the ASH3 compound, there is an electronegativity value that is not balanced between AS and H. It's causing the directions of the dipole moment to be attracted to the AS atom. Meanwhile, the other two compounds, BCl3 and Cl2, do not have a dominant dipole moment directions, or their tensile strength is equally strong and they cancel each other out. And then the third question, what is the order of the strains of the London force on the following compounds, H2, M2, O2, and Br2? So this is the answer. The order of strains of the London forces is from weakest to strongest or lightest to heaviest, namely H2, M2, O2, Br2, because the mass of the relative molecule Br2 larger than O2, larger than M2, and then larger than H2. And then the last questions, which of the following compounds? And this question you can see there are three compounds, which has the highest boiling point. So the answer is the ethanol and carboxylic acid compounds will have the higher boiling points of the three compounds, because ethanol and carboxylic acids have OH group, which are a requirement for hydrogen bonds to occur. Then carboxylic acid has the highest boiling point compared to ethanol, because carboxylic acid has two oxygen atoms, which makes more hydrogen bonds to form compared to ethanol, which only has one oxygen atom. So that's all for the explanations that I can tell you for today. So thank you for your attention. If you have any questions, you can ask on a comment column. So don't forget to like, subscribe also. See you, goodbye. I am YOHANA ELISABET. Say thank you for your attention. Thank you.